Alright, so we've already done several examples writing the formulas of ionic compounds, but here we're going to go from the names to the formulas, and then also from the formulas to the names. Now, in this video, we're going to look at compounds where we specifically know what the charge on the metal is going to be. Right, and so those metals are alkali metals, which we know are going to be +1. Alkaline earth metals we know are going to be +2. And then we know aluminum is +3, zinc is +2, silver is +1. So if it's any of these metals, these are the rules that we would use. And so it's pretty easy. All you have to do to name them, if we have a metal plus a non-metal, just state the name of the metal, and then state the name of the non-metal, except the suffix of the non-metal is replaced by IDE. So chlorine, for example, chlorine becomes chloride, or oxygen becomes oxide. And if we have a metal plus a polyatomic ion, then it's even easier. Just state the name of the metal and state the name of the polyatomic ion. You don't have to change the name of the polyatomic ion at all. Alright, before we get to that, let's do a couple examples of writing the formulas from the names. And so we've done these before. Calcium chloride, I go and look up calcium. It's an alkaline earth metal, +2. Chloride, that's a chlorine ion, so that's going to be Cl-, and so then that's going to be CaCl2. Right? If you see an IDE other than cyanide, which is a polyatomic ion, this is going to be a monatomic ion. Right? When we come here and we have potassium sulfate, we have to be careful, right? This isn't sulfide. Sulfide would be S2-. A sulfate is a polyatomic ion that's SO4 2-. So potassium, the metal, is an alkali metal, so +1 charge. So then our formula is going to be K2SO4. Right, when we go to barium phosphate, barium is an alkaline earth metal, +2. Right, it's not phosphide, so it's not just a phosphorus, it's phosphate, so it's a polyatomic ion, so that's going to be PO4 3-. So now when I swap the charges for the subscripts, we're going to have Ba3. I need 2 phosphates, so I put it in parentheses, PO4 2. And then lithium nitride, IDE, this is a monatomic ion, this is a nitrogen, so I have Li+, nitrogen 3-, and so I'm going to need Li3N. Alright, so let's practice going the other way. I have the formulas, and I want to give the names. So I look at the first one, I know it's ionic because I have a metal plus a non-metal, and aluminum is one of the metals where I know its charge. I know it's +3, so I don't have to do anything to specify it. I can just say aluminum, and then give the name of the non-metal, but instead of fluorine, I would write fluoride. Right, now I have another example. I have magnesium and an acetate ion, so I have a metal and a polyatomic ion. So in this case, just give the name of the metal and the name of the polyatomic ion. So in this case, I have magnesium and that polyatomic ion is acetate. Right, now this one is a little bit of a curveball. Right, NH4+ is one of our polyatomic ions. This is the only polyatomic ion that you're responsible for that actually has a positive charge. But in this case, we name it just like the other ionic compounds. Instead of giving the name of the metal, we just give the name of this polyatomic ion. And that polyatomic ion is ammonium. And the second polyatomic ion, NO3-, is nitrate. Alright, we have another metal, zinc, plus a non-metal, sulfur. Zinc is one of the metals where we know its charge, we know it's +2, so we don't have to specify it. So I just give the name of the metal. And then the non-metal is sulfur. I chop off its ending and replace it with IDE. So I have zinc sulfide.